Hey guys, welcome back to another video. Time we gone over how you can destroy the entire world. I was bored. I was doing some research on a little project I'm working on, and I learned this thing that you can literally just like destroy the entire universe. And it's called vacuum decay. Basically, it is a potential end of the universe where it's very, very unlikely, but it can be triggered. Basically, it's when the universe is okay. So the energy levels, of the universe, right there. For example, oh my God. Okay, it depends on what we're talking about. Let's just talk about the most common one, which would be, well, it's just none of it's common, but the main one, the one that most people talk about, which is the Higgs field. That is like mass. The Higgs field gives things mass. A higher energy level would make it more powerful, and a less would make it less powerful, blah blah. But there's a thing, because right now they think very most likely, it is not at a super stable state. It's at a low energy state. But it's not. It's a false void though. It's not a vacuum. So they think that there's a chance that it could go to a more like just from s- English is hard. Okay, think of it like a hill, and it is at like the top of the hill. It's not at the top, but it's good. It's a good way to think about it. There's a chance that it could roll over into a more stable position at the bottom of the hill. Very rare, very unlikely to happen. But it's not really rolling per se. I mean, with like with some other type forms of what do you call it? Fields. Like I know with the inflation field, it is more of rolling. With the Higgs field, it's not rolling down. It's what do you call it? Quantum tunneling, I'm not going to explain it all 'cause it's really really complicated, and I'm dumb. But basically, to know where an electron or a particle is, it's not. It's there. It's not. It's like right there. It is where could it be? It's a probability. And it's never zero. The probability is never zero, I think like 99% of the time. I think there's like a couple ways where like depending on the thing, it can't be on something else, depending on the type of particle, blah blah. But basically it's never zero. So there's always a chance that it could be across a wall. Like let's say there's a wall in between. There's a chance that it could be on the other side of the wall next time you look. And now that is quantum tunneling really, really, really simplified, where there's a chance that it could be on the other side of something. It could be anywhere. So the universe, the energy level could basically go through the hill. Like it doesn't go up and over. It doesn't even really go through. It just is on the other side of the hill. It doesn't teleport. It just is on the other side of the hill. Because there's always a chance it could be there. And I'm really dumb, so I don't really know if I'm explaining this right. I'm a dumbass. Basically, that is kind of little what it is. So the universe could go into that form, which is a more stable energy state, and basically everything dies. And it doesn't really die. Things just stop working. It's not like it's not really like okay. It's a ball of low energy, like a lower state that expands at the speed of light, and there's no way to tell it's coming because it's at the speed of light. So but you won't even know it's there. It'll just be like when you lie. You kind of just cease to exist. The thing is, it doesn't like kill you. You don't explode. Just the physics that make you up stop working. Like you will just fall apart. Your atoms will just stop like being bound. Like is it vacuum decay, Higgs field? Maybe this will give a better explanation. Up. But yeah, the thing is just there's always a chance. Like it says here, the trillions of years before it naturally occurs. It's not a time. Like it's not like a time there's not like a set amount of time it takes, but there's just such a small chance that it could happen anytime. It could happen right this second. I mean that's just a fact. Very unlikely, but it could. Most likely. From what they think. From what the smart people think. Apparently, okay, so I was doing some research. It can be caused by other things, but nothing practical. Like even like the biggest things, like black holes merging, neutron stars colliding, all these very, very powerful things still can't cause it. It needs to be so dense, and so because you need to excite the Higgs field enough for it to like. I don't. I honestly, I'm pretty dumb. But you have to excite the Higgs field enough for a long enough period of time, because basically exciting it sort of like opens the door. I'm pretty sure, but you need to hold it long enough for it to randomly do it, because it's not something you can do. It's just a chance. You open the door and the chances are higher, but it still could never happen. It's weird. But yeah, I thought this was really cool. Just wanted to talk about it. I also learned that there is other ways. Like apparently there was a field. It's called the inflation field. It still exists because thing is, after it decays, even if it goes to like the lowest it possibly can, which is never zero, but it's still low, it doesn't go away. It merely just stops being a major factor. Like apparently they think the inflation field was a massive thing. It was like one of the biggest, if not the biggest field. But its whole it sort of rose up like a graph. It slowly rose up and then it slowly rose down. And it rose down is its own version of vacuum decay, but it's slower. So instead of it being instant like a vacuum like the Higgs field one, it's more of a slow things stop working slowly. Like chemistry just stops working because it's really hard to explain because I'm dumb as shit. If you want, you can of course Google like a smart guy video. From my understanding, it's like things just don't work the same. It's not that things are getting destroyed. It's that the yeah. That's basically it though. Honestly, I don't know what I'm yapping about, but yeah. Bye.